All right, y'all. We're going to start on page 389 in your books, 9.2 data distributions and outliers. But before we do, I would just want to take a look back and revisit a handout that was part of your review packet for the quiz. If you look at the reteach handout from lesson 9.1, you go to the bottom, there are step-by-step instructions on how to use your computer to find the mean, the median, first quartile, third quartile, as well as the standard deviation. Gives you pretty much everything but the interquartile range, as well as the range. I'm pretty sure at this point you can do those on your own. But if you didn't do this, you didn't read through this section, and you're not sure how to use your calculator, go ahead and pause the video and try a couple of these examples. Get used to using your calculator. It's going to save you a lot of time and energy. When you're ready, rejoin us on page 389, and we'll start the notes. All right. Page 389, 9.2 data distributions. Our essential question, what statistics are most affected by outliers, and what shapes can data distributions have? It's funny that we've been using the term statistics all along and haven't actually defined it yet. But don't worry, we're going to get there in this section. So on your next flap in your foldable, you want to label data distributions and outliers. All right, and our first definition is going to be a dot plot. Funny name, not a funny definition. A dot plot is a data representation that uses a number line and x's. All right, you can indeed use dots or other symbols. I'm going to use dot plots. We can also sometimes call these line plots just because they are linear, or you have the one-dimensional plot. So skipping down, let's take a look at our explore examples. We're given this example with finance, a bunch of salaries, right? And it says choose the number with the most appropriate scale for this problem. Well, if we're looking here, our scale, we can see 25, 30, 35, 40, 40, 45, 45, 50, and 60, going by fives. But we also should note that the range is 25 to 60. So 0 to 100 seems like a little much. 20 to 95 also seems like much. Here we notice the middle one has a labeled scale of 10, but in fact each hash mark is worth 5. So this is probably going to be our most appropriate scale. And that would be because the range we can say is 25 to 60, which seems appropriate. This one goes to 70, and it goes by fives. Next, take a second to do example B and fill in your own line chart with the frequency for the occurrence of the salary measurements. So let's take a look at what you got for your line plot. Should look something like this one. Note that, again, my frequency, I put 10, 20, 30, 40, 50, but the hash marks were worth 5. All right. For my reflection question, you just wanted to read over this. I said that it's a number line and therefore it's quantitative. Right? This is things that we can measure using actual numbers and not just counting the categories up. Next, I'm on page 390. We're going to look at the effect of an outlier and how to identify an outlier. So your next definition in your foldable should be outlier, of course, and that is a value in the data set that is much greater or much less than the other values. A better definition would be to just copy this into your notes. Hopefully at this point in time you can read that equation and understand what is meant by those symbols, but let's walk it through and you can include any notes that'll help you remember it in your foldable. So it says a data value x is an outlier if x is less than the first quartile, so that's the median of the lower half, minus 1.5 times the interquartile range. All right, that's Q3 minus Q1, or if it's greater than the third quartile plus 1.5 interquartile range. Okay, and we'll be able to recognize outliers quite a bit as we move along. On example A, so we go back to all of those salaries and we add on the boss's salary, which is way more than twice everybody else's. So they choose an appropriate scale. You see, we can notice that this information is way out in left field, so it looks like an outlier, but we just want to test whether it is or not. So again, go ahead and stick these numbers into your calculator. So your calculator screen should now look like the screen on the page. If you're not sure how to get this, once again, go back to that reteach 9.1, look at those directions and go through with it. Just taking a look at what they do here, notice again 150 is the quantity that we're not sure of being an outlier or not. When we take the third quartile, which is listed here, and add 1.5, the interquartile range, which is the difference here between those two, 47.5 minus 35, we notice that it's definitely true and 150 is an outlier. All right. Pause the video, try example B on your own, and then we'll walk through it in just a second. All right, so on part B, we see that the owner's salary is now $65,000. So he's not making way more than everybody else, he's just making a little bit more. So let's take a look at your data values. At this point, you should have read through everything. Notice, again, I went with 10,000 as the label interval and 5,000 as the actual interval of the line graph. Finishing up example B from Explain 1 on page 391. Again, we get a good view of what your calculator screen should look like. Just filling in a couple more values. Notice that now, with the boss's salary far lower at 65,000, we get a Q3 plus 1.5 interquartile range of 66.25, which of course means that it's not an outlier. Take a second now, pause the video, read over the next two questions, the reflect number 2 and the your turn number 3, and I'll meet you back at the bottom of the page for explain 2. So here we are at the bottom on explain 2, comparing data sets. And we're given a ridiculous definition, but we're going to run with it. So get statistics into your foldable and know that this is numbers that categorize a data set. Numbers that categorize a data set, such as measures of center and spread. Okay, and now we're going to compare sets of data from NFL players and MLB players. Take a second and plug these numbers into your calculator. Go from list 1, if you just click over, it'll go straight to list 2. And on the next page, we'll see a great example of this. Okay, so now I'm on page 392. Notice that I have the two lists that should look similar to the ones in your calculator, highlighted as NFL and MLB. You should be able to, at this point, use the stat button to find the NFL stats. Do so now and compare your numbers to the books. For the second list, in order to do that, I have directions under example B. So let's just take a look. The first thing you're going to do is, again, hit that stat button, hit number 1 for the variable, one variable stats, and then it'll kick you back to the home screen. Hit second stat, which notice that above it, it should say list, and just select the second list or hit number 2. And your home screen at this point should say one variable stat. L2, hit enter, and it's going to give you all of the stats for the second list. All right. So again, compare with what they got in example A. Hopefully you're going through this and getting good with a calculator. And then give example B a shot on your own. And we'll rejoin and talk about our data in a second. So here we are with the stats that you should have pulled off of your calculator. Then we have this big long paragraph here. It says the mean is lower for the second game show, which means that the contestants in the second game show were on average younger than contestants in the first game show, right? Comparison, younger than. However, the median is lower for the first game show, which means that although contestants are on average younger in the second game show, there are more young contestants on the first game show. Finally, the interquartile range and standard deviation are higher for the first game show, which means that the ages of the contestants on the first game show are farther apart than the age of the contestants on the second game show, right? And that makes sense. I mean, take a look and just study those numbers. You'll notice that they're a little bit more spread out. They're not centered. And that tells us a lot about what these two numbers mean and how reliable they are as descriptors of each show, as statistics, if you will. So flip over to page 393, and you'll see your turn, number 4. Give that one a shot, fill everything in, answer the questions, and we'll go over that. When we pick up, we're going to be on Explain 3, comparing data distributions at the bottom of this page. So right away, we're given some more definitions. It's best if you have room on your foldable to get these in there or even draw them on the back, all right? Symmetric, skewed to the left, skewed to the right. Get these pictures in, all right? Notice the skew is that these guys are just kind of a little off that way, a little off that way, making it slide out to the direction that they're saying it's skewed to. And the symmetric one just kind of looks like a bowl flipped over or an upside down parabola, generally symmetric, the same shape on each side. And then let's take a look at example A. For each data set, make a data plot and determine the type of distribution, then explain why. So here it's important to note that they're using a measurement of miles, and that's what I'm going to name my dot plot or my line plot. And we'll pick that back up on page 394. So on page 394, we can look at their dot plots. Notice that Team A is even and pretty symmetrical, while Team B's is clearly skewed off and to the left. And evenly here, and distance skewed to the left. Give B a shot. Create your own line plots, and then we'll pick up in just a second. Here's what I got for my dot plots for the apples sold by two different stores. Grocery store A looks pretty even, while grocery store B looks skewed to the right just a bit. Make sure yours looks similar. Make sure you decided on an interval that made sense. I have a couple extra going by hundreds. It still seemed to be the best, as each interval was 50, so each hash mark was 50. Take a second and answer reflection questions 7 and 8 at the bottom of this page, and then your turn number 9 on page 395. We'll check those next class. And that's about it. We'll do some homework problems in class. Please let me know if you have any problems. Email me, get to Math Lab, and I will see you next class.